As another example of an improper integral. Improper because the endpoint of integration is infinite. So let's take a look at it. What we want to do is define this as the limit as some big number goes off to infinity of the integral from 0 to m. So we just turn the problem into a problem where we actually have a finite, well-defined integral. This thing here, who knows what it means? It's some infinite area, which is strange. But this thing here is just some finite area which we're comfortable with. So we define the problem in terms of that, and then we take the limit. So this is going to be the limit as m goes to infinity of, you know what? Got ahead of myself. Let's think about this integral. This integral we do with parts. So u of x, we let be x, and v prime of x is e to the minus x. That means u prime is 1, and v is minus e to the minus x. So our integral, we have the limit, and our integral is, from integration by parts, u times v, so minus x e to the minus x, from 0 to m, minus the integral of v times u prime, so that's a negative e to the minus x dx, from 0 to m. So this is the limit as m. We'll take the limit at the end. I'm just going to keep writing it for correctness sake. Plug in m here. I have a minus m e to the minus m minus 0. And then this integral, we know the integral of the negative signs cancel. It's just the integral of e to the minus x, which is minus e to the minus x from 0 to m. That is the limit as m goes to infinity of minus m e to the minus m minus e to the minus m, let's see, minus negative 1, so plus 1. All right, so we take this integral, and as m goes to infinity, this part right here is an indeterminate form. It's infinity times 0. But we know that the exponential function decays faster than m can grow. We know this is going to go to 0 overall, or we could use L'Hopital's rule if we need to use L'Hopital's rule on it to show that the limit is 0. So that goes to 0. E to the minus m as m goes to infinity, that goes to 0. So we're left with just 1, which is purely coincidentally equal to the answer in the previous example in the lecture notes. That's just a coincidence. They don't always come out to be 1, but in this case, the answer is 1.